Hey peeps, Thrill here. This is my write-up for HackTheBox's Cascade, one of my favorite machines involving a lot of enumeration and reverse engineering created by Baby Scrub, and it doesn't have much exploitation but still a great machine. Starting with hand map, we can do take A for full scan, and we see a lot of ports open as you would expect from a Windows machine. The ports we are looking for is LDAP. It leaks the domain name, which is cascade.local, and we can assume that it has anonymous login enabled because of course nmap was able to find the domain name. Now we copy the domain name to our host file, which means we can call the machine with it, and I've already done it. We can now use LDAP search in order to see what data LDAP gives us with anonymous login, and I used LDAP search tag H for host, which is our machine, and I can just write domain name now. Tag X for simple authentication, then tag B for search base, which would be cascade.local, and we can specify it using DC, which means domain component cascade and domain component local. And we can see we get bunch of data which we cannot analyze manually, so we decide to route it through a file called LDAP. Listing the files, we can see this is a 227 KB file, and we can use grep in order to find any sensitive data. But first we do head on it, so we can see that it is requesting all of the attributes of all users. This is important, as we will see later. Graphing for pass or PWD doesn't result in anything interesting, so we use take I for case insensitive, and we find some attribute called Cascade Legacy PWD, which seems like a base64 encoded password. So we use grep for Cascade Legacy PWD, and you use tag A for heading 15 lines and tag B for trailing 15 lines around the match. Doing so, we see that it is a password leaked for our Thomson user, and we can decode it using base64 tag D. After decoding, we get the password, and now we can use SMB map to see if there are any available shares on the machine. And if we look at the syntax, it is SMB map tag U username, which is our Thomson, tag B the password, then the host, and we let it run. Gives us some information regarding the open shares, but we only have read-only access, so we cannot use psexec or anything to get a shell from it, but still we can access the shares. There is an interesting share called data, and we use SMB client in order to access it. Looking at the syntax, we see tag capital U for username, R. Thompson, and now we can specify the path to the share, which is the domain name and the share name. Pasting the password, we get in. There are too many folders available, and we can use recursively listing to list all of the files inside all of the folders. You can see we get a bunch of access denied somewhere, but we are able to access some of the files. Now, after completing, we see there are two interesting files. One is this one in IT email archives, and another one is this registry file. We decide to see this email first. Just quotations due to the space, and I used more in order to just see the mail. Now ignore this bunch of things, text, it is an email, that's why it is like the fonts and stuff. The interesting thing here is the paragraph. So this paragraph basically tells us that they were going through some network migration, and in order to be more secure, they had to delete the admin account, and they created a new temporary admin account called temp-admin. And they tell us that the password for that account was same as the normal admin account. So basically they gave us a hint for having root to this machine. If we get to the temp admin account's password like we did for our Thomson, we can basically get the password for admin account. This is due to the fact that there is something called AD recycle bin present in the machine. But more of that later. Right now we can look at the other file, which was the registry file. Located in this folder, we decide to go through it, and we can use mget in order to download the file. I use mget because it supports regex, so I just had to write vnc star, and it will get the file for me in my machine. So looking at it, we see our registry file for something called tightvnc application, and we see an encrypted password in it. So this file will be created by installing a VNC application, and it's storing the password using guess AES encryption, which is normally used by VNC or any applications these days to store the password. A simple Google search for VNC password decrypt or anything like that would lead us to the key used for storing the password or encrypting the password, as someone would have done by reverse engineering the application. Some Googling around, we find a GitHub post involving a MSF console and spawning IRB shell in order to decrypt the password. And we can see here that it uses a library and the fixed key, which they got from reverse engineering the application. This key is required to decrypt or encrypt the password. In this case, we will decrypt it, of course. We import the library, and this library contains the exact algorithm which was used for encrypting the password. We use it in order to decrypt our encrypted password we found earlier, and we get the plain text of the password. So basically what we did was we found a registry file which was created by installing the tightvnc application. We used the things mentioned in the GitHub post in order to decrypt the password stored in it, and we found this password for s.smith. Now we can exit out of this and we can use WinRM. As this is Windows Server, there is a chance that it would be running WinRM, Windows Remote Management. We type in the user and password and we get in. Now we can get the user flag. Going to the desktop and using dir, we can see that the user flag is present. We can successfully get it. Now going back, we can use tree command in order to recursively list the files, and we can see there is nothing interesting of anything else. So we decide to go to the root, which is the root of C drive. We can use dir and we find a shares folder which is not normally present there. We decide to go through it and list the files, but we get access denied. But we do know that we can use this s.smith's username and password with SMB map to see what shares does it have. Again, using the same syntax, we can use username as s.smith and the password we found earlier. Now here we can see there is a new hidden share called audit, hidden due to that $sign. Also read-only access, we can only use psexec. So again, using SMB client in order to access the audit share this time. Pasting in the password, and we get in. Listing the files, we see there is an application there, which is actually a .NET Framework application. And in order to decompile it, we will need ILSpy with .NET Framework installed in Linux. But on Windows, we can use the nspy, and it has, of course, the .NET Framework installed in it. So I'll be moving to my Windows machine, where we can do the decompilation and rest of the box there. Alright, I'm on my Windows machine, and as you can see, my OpenVPN is connected and ready to go. So I use run in order to access the share with IP address and the share name. It's the syntax. And it asks for a credential. We use s.smith as username and the password. I think I have my clipboard. Yes, I do. Paste in the password. And let's see, yes, we get in. Copy all the files to our local machine, and then we can decompile it. Now, as you can see in the DB folder, there is an SQLite DB file, and you can use any application. I used the DB browser for it to open it, and if we look at the tables, there are 4 tables, and we can browse data among them. The table we are looking for is the LDAP table, which contains the username column and a password column. So the password column contains a base64 encoded password, and this is of course for the ArkSvc user. So we'll see what to do with it. Now, this is the application that we need to decompile, so I'll use dnspy in Windows for decompiling it. Let me just open it up. After opening the application in dnspy, we get to see that it is a .NET Framework application, and dnspy will be helpful in decompiling it. We also see that it loads something called Cascrypto.dll, and there is a module called Cascrypto in it. Decompiling it, we can see that there are two functions named encryptString and decryptString in it. And we also see that it is using AES encryption and uses this IV for encrypting or decrypting it. But we still need the key, so we go to main module and see that it selects from the password from LTAP and encrypts it with the following key mentioned right here. So now we just copy the key and IV to a notepad file, and we can use any decryption software available online in order to decrypt it. The IV from the functions, there it is. Now we can just search Google for any AES decryption tool online. Anyone would do. Here we have to use CBC mode as it supports IV, initializing vector. It is optional, but we should copy and paste it because we have it. Opening the file, having the encrypted password in it, and we just copy and paste it. We also see that it is encoded in base 64, so we will have to select it, but it is already selected. Decrypting it and decoding it in plain text reveals the password for ArkSvc, and now we can log in using the ArkSvc user. Use PowerShells, get PSSession, which is similar to EvilWinRM that we used in Linux, and we can use the tech credential argument in order to enter a password, username and password. We get in, we see there's nothing interesting in the documents folder, so we do who am I. We also see that we are at, as ArkSvc, we do who am I /all, and we see a bunch of privilege which are normal, and we cannot use any token manipulation or anything like that. We see that we are in a group called AD_recycle_bin, which means we can access the contents of AD_recycle_bin, which has the temp admin and all of its attributes, which will have the password that was mentioned earlier. We can now search for something called AD_recycle_bin in Google, and let's see if we can find a command for PowerShell. Here we find a PowerShell command, which uses simply the getAD object with an argument called include deleted objects, and we try to run it. I believe there should be no space between the check and the include. Yes. So these are all the contents of the AD_recycle_bin, but we do see that it doesn't display all of the attributes, but we do need the password for temp admin right here. So we do an argument called properties with an asterisk after it, which means it can display each and every properties or attributes just like we did in the LDAP. Doing so, we can see that it displays each and every attributes information for any user that was in the AD_recycle_bin, and we do see our password for temp admin, which is, of course, as mentioned earlier, is the same as the normal administrator account. I use CyberChef because this is Windows and it doesn't have base 64, so CyberChef's decoding would do. Now we find our password for administrator, and we can just log in as administrator and get our root flag. Pasting in the password, we get in. We go to the desktop, list the files, and we see our root flag. And we successfully root the machine. This machine was easy to medium in difficulty. We learned about LDAP, a recycle bin, and also decompile the .NET Framework application. We also see that misconfigured LDAP allows anonymous login, and there should not be any sensitive information like the password in Active Directory. And this was my first write-up for my favorite HackTheBox machine right now. I'll be doing all of the challenges and machines as much as I can do for HackTheBox write-ups, and I'll see you all next time.